Okay, so what we're looking at now is critical path development. So it's developing, working out what a critical path is. And what that essentially comes down into is a scheduling issue, as we say here. Okay, it's about allocation of time, when parts of a project are going to finish, and therefore when other parts can start, and all that sort of stuff. Okay, you have these sorts of things occur in a wide range of areas. In building a house, you're going to have scheduling of when plumbers come in, when electricians come in, and when roofers, and when you lay the slab, and all that has to be timed. And when you're doing that, you're basically doing a scheduling problem, which is you need to work out where the critical path is. Where is that point where there's no give? It has to occur on that time for things to move forward. Okay, so that's what we're going to be looking at. So scheduling problems involve analysis to to determine the minimum overall time it would take to complete a project. So how do I get from start to finish with all the different components that are going to be occurring? Okay, and so we're taking from our immediate predecessor part. So which is our immediate predecessor stuff that we've done previously in one of the other questions. One of the videos. What we've got here is the estimated time. So this is where we're saying for activity A, it's going to take this time, etc., etc., etc. Okay. What's different here now is that what's different is you put in you have your sort of thing like this where you've got your predecessor table as noted before. You're going to go A, C, E, whatever you've got there, but you've got a number. So that 8, let's actually use a highlighter. And we're going to use, so that 8 corresponds to there. I won't do them all because I only want to pick 4 colors. The B6 is here. The C, and as we learnt with dummy activities, there's a dummy activity here because C has 2 partners. Okay, so C is here and essentially going down to there, so F can start as well. All right, so that's C. All right, and down as you go. All right, so this is what happens. So you can take your predecessor activity, you can then make your activity network, and then from there you put the associated number. So wherever there's A, you put 8, or in this particular case, B is 6, C is 1. That's all you have to do once you've put the network together. All right, so that's a starting point. So it moves on from there. So as we go through, we'll talk about float time. So basically the idea of a float time is, the easiest way to think of it is, this activity takes 6, so it could be 6 minutes, okay? But I can't move past here, so probably going on to activity D, until I finished A and B, all right? A is 5, so I'm going to take, say, 5 minutes. This is going to be 3. So coming in from this direction here, it's 8. Coming in from here, I've got 6. So I can't, so basically what it's saying is this part's going to move, but I've got a float time here of 6 because I can't move past that point there until I've reached 8 minutes. This one only takes 6 minutes, so I can say start after 2 minutes, take my 6 minutes, and then we can move on. And then it's equal to the 8. So that's what a float time is. And that's basically what we're calculating. So it's basically, we'll get to what that is and how we can use that from our analysis in a moment. Okay, so that's the idea of what we're talking about so far. I'm going to skip past that. I'm going to do what we call the forward scan, the backward scan together, but I want to show you some of that little bit of theory here first as what it is, and then I'm going to show you how we can do it. Okay, so what we're doing, what we call a forward scan. So we're basically going across, we're going in that direction, okay, across the activity network in that direction. That's why we call it a forward scan. And we're looking for what's called the earliest start time. So what that means is, say, for example, I get to C. For me to start activity C, I have to wait 8 minutes or whatever it happens to be. That's the earliest I can start. The earliest I can start here is, for activity D, is 6 minutes. And as I'll show you as we go through how you work those numbers when you got, say, converging lines coming in, some converging edges coming into that, into say here, how we manage that. But this is what we call, and this generates our earliest start time. It's what we call a forward scan, okay? Skipping ahead to where we talk about what we call a later start time. In a later start time, we call it backward scanning because we're starting at the finish and we're going in that direction. Okay, so it's a reverse process. So what I should have said here, when we get to a point, say here, we're looking for the biggest number, my shorthand for number. When we're going to backward scan, going backwards, it's going to be the same process of doing it, and I'll show you in practice how we use it. But what we're looking for is the smallest number. Okay, so that's what we keep in mind as we go through. So what I'm going to do, and we'll come back to some float time stuff in a moment. Now, what I like to do with this, something like this, is to use different colors. So I would suggest having different colored pens. Just note, there are a couple different ways I often use on how I use black and red. Doesn't matter whether you've got blue and black, if you've got your pens, whatever it happens to be. There are a couple different ways to visualize this. Different teachers have, I know there's within our school, there's two or three. I got one way. Some of the other teachers have a slightly different version of what I do. And another teacher uses other different ways. All are perfectly fine to do. All users will end up with the same answers. It's just a slightly different visualization of what you've got. So the only other difference is I tend to not have these boxes at the start. I'll have one box, or I'll have two, but I'll explain that in a moment. So basically what we're doing here, we're saying from A, so from the start point, I'm going to have to put 0 and 0 here. And the reason I put 0 and 0 is that that's the earliest I can start at 0 because it's your starting. As I get to C, for me, that C, this part, the number I put here is 8 because before I can move on to C, I've got to wait 8 minutes. So that means I put 6 here. I come across 1 here. Okay, so I've got 9. So before I can start activity E, which is here, I've got to finish activity C, which means I've got a total of 9. So I've got 8 plus 1. Now, here's where the dummy activity comes in, we've talked about previously. For me to go activity F, I need C and D to have finished. So that's where I go C, come down here, and it's 9. So because that's when C would take. What I do is I'll write C here, put a 9 next to it. Now I'm going to go from here, I'm going to go D for D. That's 2. So coming from D, I've got a number of 8. So it's 6 plus 2. So I put the biggest number. So I put a 9 in here. Now I come in where it's looking where G is going to start, the earliest start time for G. Okay. Now I've got numbers coming in from E. So I'm going to put E here. E, that's going to be 9 plus 3 is 12. From F, I've got 9 plus 1, which is 10. So I put 12. So I picked the biggest number, remember. And these ones here, it's going to be G, so that's going to be 14. So it's 12 plus 2 from the G, then plus 1 from the H. Now, here's where I use a different color. I'm going to start here at 15 because that's when it. So the earliest finish time is going to be 15. So if you've got a question that says, when's the earliest this project can be completed? 15 is your answer. Okay, so that's the earliest, earliest finishing time there. So what we're looking back. So I'm going to start at 15. So basically, when I have these boxes, this is for earliest start time. This is for latest start time. All right. So now I've got 15. I start at 15, my latest start time. 15 minus 1. So I'm going to go back. So I'm going in that direction of the arrow. So back, it's 15 minus 1 gives me 14. Then I go 14 minus 2 gives me 12 because I'm taking from there. Now, I go up to this point here. So remember, my arrows are going this way. So, but remember, I've got a one coming from this direction as well. So I've got to take both into account. So coming from E, I actually have to get rid of this now, just for a moment. Skim away. For E, coming in from E, I've got 12 minus 3. That's going to be 9. Coming in from F, so let's have a look at that. So coming in from F, I'm going 12 minus 1 would be 11. So that means I'm going to be putting 11 in here as it is, okay? But it also means coming in from here, it's 11. So coming in from F, it's 11. So because of that dummy activity. So in this case, remember, I picked the smallest number, I go 9. Then I go 9 minus 1 gives me 8. 8 minus 8 gives me 0. This one here, I'm going to have 11. 11 minus 2 gives me 9. 9 minus 6 gives me 3. Okay, so we're saying I do a slight difference, and I'll show that on another one, but that's basically how, so for A, so this is where you'd be saying, and what you're looking for here, so we'll come back to this. What you've got, let's have a look at this. Identifying float times and a critical path. So what you're trying to look for here is this sort of thing here. I'm looking for a difference. So that one, a difference would be 3. That would be a difference of 0. So if I see 0, there's no flexibility. Okay, it has to happen on those times. That means I've got no flexibility. It means I've got a critical path. This means I've got a float time, so I can delay it up to 3 hours, and I'm okay, or 3 minutes, whatever the time is. Okay, and this is the important point here. I'm just going to sort of circle it, highlight it like this. The critical path is a sequence of activities that cannot be delayed without affecting the overall completion time. We're going to go back up to what we did, and we'll look for that part where I cannot delay it. And this is a nice sort of summary of this process. So how you get the float is your latest start time. So remember, EST, let's actually draw it in there. I'm going to go EST, and then I'm going to go, oops, I don't know what happened there. I'm going to go LST. So it's this value, subtract that value. Okay, and if that gives you a 0, it's part of the critical path. So let's go back up to here. So if we look at this, anywhere we got, so this is going to be a critical part of the critical path. Part of the critical path. If I go down for F, I've got a float time of 2. Here, I've got nothing, it's 9, so it's going to be 0. Critical path, part of the critical path, part of the critical path. Okay, so that's your critical path. So you'd say your critical path of this network activity would be ACEGH. Okay, so that's the process you need to follow to work out, to do a critical path analysis, and that's what we've just done for earliest and latest start time. Okay, so that's our critical path analysis. I will do another video showing another worked example, and then following on it from that, we'll do one with some crashing as well. Okay, thank you.